big electrical network, only a small portion of a big electrical network, say, could be an arrangement of three resistors. Say this is R1, this is R2, this is R3. Where A could be connected to an electrical network, some current could be entering A somewhere, B could be connected to, let's say, some other electrical network, C could be connected to some other electrical network. So this is only part of a bigger electrical network. Only part of a bigger electrical network. And this element of a bigger electrical network, this kind of a topology is called a delta. This kind of a topology is called a delta. It's called a delta. This topology could be reduced to an equivalent topology. It could be opened up like this. This topology could be reduced to a topology like this, ABC. Say where this resistance becomes RA, this resistance becomes RB, and this resistance becomes RC. And this topology is called a star topology. It's called a star topology. Sometimes, to simplify matters, we convert a delta into a star, or sometimes we convert a star into a delta. We'll realize when we solve problems, we'll realize when to convert a delta into a star or when to convert a star into a delta. But then, say, given R1, R2, R3, I must know what RA, RB and RC is in the equivalent. Or, given RA, RB, RC, I should, if I want to convert into this, then I should know what R1, R2, R3 are in terms of RA, RB and RC. The equivalence has to be known. Now, if these two networks are the same, if these two elements are the same, then what it means is that the resistance between A and B here must be the same as the resistance between A and B there. To create electrical consistency, the resistance between A and C here must be the same as resistance between A and C there. The resistance between B and C here must be the same as the resistance between B and C here. That will create electrical consistency towards equivalence of these two networks. These two elements, rather, they are part of a bigger network, say. ABC could be just junctions. And I want to convert this to this or this to this, depending on what is required. Now, when I say resistance between A and B, what I mean is, whenever I say find the resistance between A and B, what I mean is, I imagine a current to be entering A, flowing through this network and leaving B. This is what it means. When I say find resistance between A and B, it means imagine a battery to be connected across A and B. The current therefore enters A, it circulates through this in various manners and it leaves B. The total resistance encountered by this current, during this entire journey where it enters A and leaves B is the resistance across A and B. This is what it means, right? Now, when this current, so resistance across A and B for this topology must be the same as resistance across A and B for this topology. Yes or no? Right? Now, when current enters A, see, part of the current goes through R2 and R1, part of it goes through R3 when it leaves, which means R2 plus R1 will have the same current flowing through them. So they would be in series and R3 would be in parallel across this series combination. So it's like R3 in parallel with R2 plus R1. Yes or no? It's like R3 in parallel with R2 plus R1. Yes or no? Right? So can I say resistance across AB is like R2 in parallel, R3 in parallel, R3 in parallel with R1 plus R2, right? Which is like R3 into R1 plus R2 divided by R1 plus R2 plus R3. Do you understand? If these two are in parallel, the equivalent resistance would be this into this divided by this plus this. Right? And that must be the same. If this is equivalent, then the R across AB must be the same. Right? Which means if you imagine current to be entering A and leaving B, then the only resistance that if it enters A and it leaves B, then the resistance that it encounters is RA plus RB. Is RA plus RB. So that's RA plus RB. Now I've opened it up. I've opened it up. So this current, if it enters A, eventually, and it's connected to a battery like this, if I have to find resistance across A and B, what I mean is that everything is like this only. And there is a battery connected this way. Then this current will only circulate like this, it will leave B. That's the only way it can happen. Right? That is what is meant by resistance across A and B. Isn't it? So that's RA plus RB. Similarly, if I have to say RBC, resistance across BC, that means imagine current to be entering B and leaving C. Then this series would be in parallel with R1. If I have to find resistance across BC, that means if current enters B and leaves C, then R3 and R2 would be in series in parallel with R1. Right? So then R across BC is going to be R1 into R2 plus R3 divided by R1 plus R2 plus R3. Right? And R across BC, if you obtain from here, that means imagine current to be entering B and leaving C, then the resistance that it encounters is RB plus RC. So that's going to be RB plus RC. Right? Similarly, across AC, that means imagine current to be entering A and leaving C. Then these two in series in parallel with R2. So this will turn out to be R2 into R1 plus R3 divided by R1 plus R2 plus R3. And R across AC here is going to be RA plus RC. Yes or no? Now, using these three equations, either you can solve for RA, RB, RC in terms of R1, R2, R3, or solve for R1, R2, R3 in terms of RA, RB and RC, right? That will give you conversion from delta to star or star to delta, right? Let me just tell you the final result without wasting time on the algebra. Delta to star. Delta to star would mean given R1, R2, R3, find RA, RB, RC. That is what it would mean by delta to star. RA. That means the resistance from A. The way to remember this is A here, go to A there. Go to A there. Multiply these two. What appears at A are two resistors, R2 and R3. Multiply these two, R2, R3 divided by R1 plus R2 plus R3. Actually, it's not difficult even algebraically. See, this is RA plus RB, this is RB plus RC, this is RA plus RC. If you add all the three, then you get twice RA plus RB plus RC. divide by 2, you get RA plus RB plus RC. And then from RA plus RB plus RC, if you subtract RA plus RB, you get RC. Nothing difficult about it really, but we'll not waste time on all of that. Okay, so that will give you RA, the resistance coming from A. If you want to find RB, that means the resistance coming from B, then go to B here. Look at the two adjacent resistors, R1 R3 by R1 plus R2 plus R3. Similarly, RC, go to C here, R1 R2 by R1 plus R2 plus R3. So this given R1 R2 R3, that means given delta, you find RA, you are finding RA RB RC, that means you are finding the equivalent star. From delta to star. These are the conversions from delta to star. Then each delta could be converted into a star if required. That could be done. Ideally, that will not happen, but every delta could be converted into a star, right? Now, given star, that means given RA, RB, RC, if you want to find delta, that means you want to find R1, R2 and R3. Then the final result is, that means from star to delta, that means given star, find the equivalent delta, convert this topology into this topology. Sometimes this might help, right? That means given RA, RB, RC, find R1, R2, R3, right? So R1, for example, R1 is like between B and C, You go to B and C here, from where RB and RC emerge. So R1 will turn out to be RB plus RC plus RB RC, and somewhere RA also has to be there, so RA. Right? I know this was perhaps when I was in, why I don't want to do these calculations one more time, when I was in class 7, there was a cousin of mine who was appearing for IIT, JEE, etc. And he gave me these equations and he said, laboriously find out R1, R2, R3 and then find RA, RB, RC, and I did that for him, because that time I really used to enjoy, you know, solving every kind of equation, give it to me, you know, I would very gladly accept. So I've done it in class 7, I don't want to repeat it now. So if you have to find R1, that means between B and C, what you go to B, and C, RB plus RC plus RB RC divided by RA, right? That will give me R1. Suppose you want to find R2, R2 is across A and C, you go to A and C. So RA plus RC, same way, plus RA, RC, and therefore B also has to be there, so RB, right? Similarly, R3, write these equations a few times at home so that you know your mind gets used to it, because in problem solving, when we actually convert delta to star to star to delta, you know, you would not want, this should be spontaneous. Okay, so R3, then for R3, A and B, you go to A and B, so RA plus RB plus RA RB by RC. So this would give me a conversion from star to delta. This set of results you want to remember, actually you want to remember only R1 and RA. Everything else you can build up, right? One more theorem which would come in very handy in our entire digressions on current electricity. Another very powerful tool which I want to teach you. Can I wipe this off?